Welcome to our channel Chaykovsky. Today I will discuss about cone name reaction in this video, and this name reaction is very important for you CSIR NET exam as well as in organic chemistry, and because they given the application about this name reaction, not asking for mechanism. Sometimes they are asking in their questions. So now I will discuss this cone name reaction. First, you know that what is this cone name reaction. This name reaction is first is called Fuchs reactions. This is one of the important name reaction for formation of triple bond from aldehyde. Aldehyde from triple bond, and this is this Chaykovsky. Chaykovsky is from preparation from a double bond from ketone by sulfur halide. So this is 2, and this is Hunsdiecker. You know already this reaction in B.Sc. This is Hunsdiecker reaction is generation from alkyl halide from silver salt of carboxylic acid, and this is the noble condensation. This is one of the important reaction from formation of alpha beta unsaturated compound from aldehyde as well as active methylene compounds. So this is the 4 name reaction which is very important for your upcoming NET exam. So let's start one by one. The Fuchs reaction. It is called Fuchs. It is called Fuchs also. It is a Curie, you know, it is a big scientist or organic chemist. See, what is the main function of the Fuchs reaction? Main function of the Fuchs reaction is from you just starting material from aldehyde and you have to get alkene as a final product. Understood? This is alkene. No, this alkene. From where starting from there you get in this. And in between many steps are there. So these steps is there. You have to get. See, it's one of the important step for Fuchs reaction. In this step, you have to modify many things. So that I will come to the explanation. And if you have to this butyl lithium and water, you have to get this alkene. So in this step, if you have to use, here I use some water as a proton source. If I not use a water, if I use some electrophile, so in that time you have to get an in this position you have to get electrophile. So this step is finally important step. That step define the exact stereochemistry. Okay, so this is this here you see here actually you use 2 equivalent of butyl lithium. And you have to get the final product. So this is the utility of this Fuchs reaction. So if you directly generally if you have to tell aldehyde to alkene moiety. So this is the final important use of Fuchs reaction. If you have a aldehyde, you have to transfer to is an alkene. So you have to use this reagents and use this name reactions. So for this you have to first understanding the mechanism. What is the inside exact mechanism? Mechanism is always possible, not exact proof, but it is a mechanism. You see, this is carbon tetrabromoate. I wrote like that, and I use triphenyl phosphine. So in situ, this triphenyl phosphine will attack this, and bromo will leave. No, and then you have to get this. What you have to get this bromo PPS3. This one, this bromo PPS3, and here I am, and then this here you see that will like that, and if you get this starting bromo PPS3 and bromine minus, so that further what happen, it is this portion is very important because that will give this another carbon, bring another carbon here. So this carbon you understood, and see this is this. Actually this step is not so much needed, you directly go to that step. Okay, so you have to this CBR3, PPS3 and BR. So if you have to this, and here you see in this step this another PPS3 is better, they are one taken on bromo and this halide will form. Okay, this halide is very important for the further PPS3 from here you already saw that will halide will like that. This is resonance form of these 2 halides. You understood? This is resonance form of this minus plus, and it is double bond. You know the resonance form. And then what happened? This halide will directly attack into the aldehyde position, and aldehyde is like that only. So then it form oxygen ring like that. Like an Wittig reaction, it will form an oxygen ring. So then this oxygen ring will black. This is black. So you have to got finally do dibromo. This is the final important step, dibromo compound. And in this step, if you use this butyl lithium, what happened? This butyl lithium, if you use, you have to get this lithium and this bromo, this R and this and H. So you have to get this lithium bromo exchange, lithium halogen exchange, and then if you use some electrophile, no. If you this step, in this step, because after the using of butyl lithium, you have to this step. This step is a very important, because if you haven't use electrophile, so it is lithium, no? If I write there, you have to see. So you see, this is lithium. If you alpha, if you another equivalent of butyl lithium use, so another lithium will come. One equivalent for one lithium, another if you use, so one lithium will come, and then alpha elimination will happen. Alpha elimination means here one lithium will go. So then like carbon will come generally to lithium, and then this will come. This alpha will go there, and this triple bond will happen. So this is this triple bond. If you not use any another equivalent of butyl lithium, so here if you use any in this previous step, if you use this only bromo is there. If you use some other electrophile from this step, if I use another electrophile, you can see na other electrophile. So what happened here? Electrophile will come, okay, and some electrophile will come, and here bromo, then another equivalent of butyl lithium you use, and you have to get this type of reaction. And here you have to previously that one here one electrophile, and previously one electrophile will come. Understood? If you use electrophile in this step, in this lithium, so you have to get electrophilic substitution and finally get this type of product. So this step is a very crucial important step of this reaction. So in time some exam they will give this crucial step. After that they use some electrophile, or they use one equivalent of butyl lithium, and what happen they will ask. Hi friends, here I give this example, 2 equivalent of CR4 PPS3, and you have to get this one. So after that butyl lithium use or anything you can use. So this step you have to see, this is the main important step of today Fuchs reactions. Okay, now I will go to the another example about this. Okay, reaction, it is called Chaykovsky reaction. What is Chaykovsky reaction? Chaykovsky reaction is so hi friends, now I will discuss about another important name reaction which is called Chaykovsky reaction. Actually, what is this Chaykovsky reaction? Previous we studied Fuchs, now Chaykovsky. This is one of the important reaction using of some important reagent which is called sulfur halides. So sulfur halides in this form, from aldehyde you have to generate an epoxide ring. Okay, generally epoxide if you have to generate, you have to adding in double bond as an some oxygen as a radical process, or any other process you have to shed, or MCPBA type reaction you have to use. So here is another one application is that you have to use simply sulfur halide and this aldehyde moiety you have to generate an epoxide. So that is a very good application about is forming in epoxide ring is a simple from aldehyde. Okay, so let's start about this. What is this? So here Chaykovsky sulfur halides with carbonyl compounds give epoxide and aziridines. If you have to double bond NH also, like imine type moiety, that also called the aziridine ring. So that is this main application. You see, if you have to use sulfur halide and if you have to this one are so this is aldehyde and this is ketone. So in presence of DMSO, this is solvent and base, you have to get this epoxide ring. Okay, so simply you have to aldehyde, you form this aldehyde oxygen also participating for formation of the epoxide. And if you use this type of NH and if you use this base, so that time you have to get this aziridine ring. So this is the main important applications of this use. So you have to see, this is called sulfur halide. If sulfur is like that, it is called sulfur halide. Another application is there, I will show you. That is you have to call alpha beta unsaturated double bond is there. In this case, if you have to highly electron withdrawing sulfur halide, that time you have to got an alpha beta unsaturated double bond formation of a epoxide ring. I will show. If you use a stabilized sulfur halide, if you have to this type of reagent, this is alpha beta unsaturated carbonyl compound, if it is, so there will be there what happen, there will be not epoxide ring, there will be form of this cyclopropane ring. So this is the application. So previously you saw that is a epoxide ring will formation, azidine ring will formation. Now cyclopropane also formation in present in place of alpha beta unsaturated compound and in position of double bond. So this is this total overall application you should remember, because in your exam they will give that these reagents and this type of thing. So that type you have to quickly remember this. Here if you use a like as an, it is called trimethyl sulfur, it is like that. Here CH3, CH3, CH3 and like that. If you use base, no, so one, it is sulfur is a very sulfur has a very one vacant orbital. So if you have a base to take in proton, that will stabilize because of the vacant orbital of this sulfur. So here I show, here is a CH2 minus, here you see this is CH2 minus, and here it is the double bond of sulfur. So in that sulfur you have to use this one, this negative. So then that negative is irreversibly stable. This is called sulfur halide. So positive and negative is there, so it is called halide. You already know, like is a Wittig reaction. So and then this negative minus ion will attack in this position, and this will form like that. So it will attack. So again, in attacking P2 carbonate, and in here O minus is there, and that will come here and that will come leave. So you have to got this epoxide formation, and as well as sulfur halide is remaining. So this is the overall reaction. So if you have to, they are not asking anytime about this mechanism. For your understanding purpose, I show you. Now I will do the another two mechanism about this. So here friends, you will see that here if you have the sulfur stabilized sulfur halide, in presence of belt it will take one proton, and that will attack there. Not that, never that will attack there, because they will already attack in this position, and that will resonance, and then OH will come and that will attack this position. So it is the overall reaction, no? And this 3-member ring, cyclopropane ring will formation. So this is this application of this sulfur halide as in formation of cyclopropane ring, and it is called Fuchs reaction. Now I will give one example. You have to try in your notebook. So friends, here you see, here I gave one type of alpha beta unsaturated compound. This is stabilized wire. This is MTBT. MTBT is a strong base, different structures, and if you get this kind of compound, so that mechanism you have to try in your notebook. And this is the overall application of the Chaykovsky reaction. And now I will go to another main reaction. Now I am discussing about one of the important reaction, which is called Hunsdiecker reaction. You already know in B.Sc it is very common reaction, but I will little bit discuss for your understanding purpose, because application is not too much broad. If sometimes too much question will come, that time you have to get the knowledge. So what is Hunsdiecker reaction? Hunsdiecker reaction is this: if you have a silver salt of carboxylic acid, see, silver salt of carboxylic acid reacts with halogen compound, give alkyl halide moiety, because it is the final product and it is the starting material. If you have a silver salt of this carboxylic acid, not other salt, only silver salt in presence of bromine or halogen moiety, it will give the alkyl halide type moiety, means RBR. If you bromine use RBR type, R equal to different alkyl group. So this is this main application of Hunsdiecker reaction. So if any simple step is there, you have to get this idea, and you have to remember, not remember it is a Hunsdiecker reaction, only you have to remember silver salt to alkyl halide. How can you come? This is also remember. So you have the idea. So here is the little bit about this mechanism. Actually mechanism is not so much stable, not so much not stable. It is called not so much experiment. It is only basics. But what is this mechanism? In presence of bromine and silver salt, it will cleave it by symmetric way, and it is called as a radical mechanism. Okay. So here is in the O dot and BR dot. So in this process, so it is O dot and BR dot. Further, in presence of heating, it will decarboxylation will happen, and you have to R dot. And that R dot, the remaining OBR is there, no? Like in this step. So that bromine that will take, and there will the RBR, and another R carboxylate radical is there, and that will again decarboxylation and reaction is going on. So this is this overall reaction process. First you remember that silver salt, bromine, symmetric cleavage, bromine radical as well as R carboxylate radical, that decarboxylation happen. That decarboxylation happen, you have to get R radical. That R radical take the proton from another this previously would-be or moiety, and then bromine will take and remaining is going on. So this is the simple mechanism of this Hunsdiecker reaction, and you have to got many examples. Simple, in place of R you have to go to another substrate, it is a silver salt, and use this bromine or any halogen, you will get this alkyl halide product.